Hey everyone, and welcome to your C++ tutorial on pointers. As you can see, I have Visual Studio Code pulled up here with our Hello World project ready to go. I'm going to delete our Hello World instruction, and to begin this lesson on pointers, I think it would be very useful to kind of go back and refresh our memory of what our regular variable is. We previously defined a variable to be a memory location that contains a value, or that can contain a value, right? It's important to make that distinction between a memory location and a value, right? So when we create an integer called number, for example, and we set it equal to 8, what's happening here is that the compiler is giving number a memory address. And in that memory address, in that memory location, we're storing the number 8, right? So that's important to make that distinction of memory location versus value, because a pointer is a memory location that contains a value of another variable's memory location. So let's define a pointer here. So it's really a variable whose value is a memory location of another variable. Now I know that can maybe sounds a little bit confusing, but I'll make this clear in just a moment. I would like to just show you what a pointer looks like really quick, the syntax for it. So when you're creating a pointer, it's important that the type of the pointer is the type of the other variable that you're pointing to. And I'll make this clear in just a moment. So we're going to point to our number variable, and our number is an integer, so our pointer will be an integer. You have to have an asterisk to tell the compiler that you're creating a pointer. Just like a normal variable, you use the assignment operator to assign it a value. Now the value you want to be the memory location of number. So to get the memory location, you're going to use the ampersand, and we'll say number. And what this does is it gives our pointer variable the memory location of number. So that's what a pointer looks like when you create it. Now, what is happening here? Let's talk about it. So what I'm going to do to explain this is I'm going to switch over to a text document where I can give you a better visual representation of what's happening here and here. So I'm going to swipe over now. Okay, so here we have two sort of segments here. We have our code segment where I'm going to write some code, and we have our memory segment where I'm going to write how this code is reflected in memory. So right now there's no code. So in memory we have no values, right? But we do have available memory addresses, right? So we have our 1, 2, 3, 4, and 5, right? So memory addresses are sequential, and they'll look something like this, but they'll have much longer strings. Memory addresses are generally represented in hexadecimal numbers. So we have our empty memory addresses here, so let's write some code. Just like we did in our Visual Studio Code window, I'm going to create an integer, and I'm going to call it number, and I'm going to assign it the value of 8. When we do this and we run it through the compiler finds an open memory address for our number variable. So our first open memory address here is our number 1. And so in this memory address, we are going to store the value of 8. Right? So this is what's happening in memory when you create a variable. Now, what happens when you create a pointer? So again, we're going to create a pointer just like we did before. And that the pointer is going to point to an integer. and we are going to set it equal to the memory address of number. Okay, so now we have our integer pointer, and it's pointing to the memory address of number. So what happens here is we know that this is the memory location for our number variable. We have our value of 8 here, and this is our memory location. So when we create our pointer and we take the memory location of number, what we're doing is we're taking this memory location and we're putting it into our value for pointer. So let's say that pointer gets stored here in our 002 memory location. The value of this memory location is going to be the address or the memory location of our number variable. So that is what the value of our pointer would be, right? So when we reference our number, so if we wrote some code such as, cout, so we're going to print out the value of number. If we printed this out, this would print out the number 8. If we did the same thing and we printed out our pointer value, what do you think it would print out? It would print out the memory location of number. So it would print out our memory location here. So let's go take a look at this in Visual Studio Code. So I'll swipe over, and we have our code here. So now let's just write in the code that I just wrote in our previous text document. I'm going to print out number. So I will actually, I'm going to print out, oops, sorry about that. I'm going to print out here number value. I'll print that out, and I'll do an end line here so we get a new line. And then I'm going to print out number memory location. And I'm going to print out the value of our pointer. Create an end line here. And so I am going to use our G++ compiler to compile our program. Took a minute there. And then I'm going to run our executable. And here you see it. So we have our number value, which is 8, right? So that's the value of number. And then we have our number memory location, which is the value of our pointer, right? And it's our hexadecimal memory address there. And remember, we got that by using this ampersand, right? So when you use the ampersand in front of a variable name, it's taking the memory location of that variable. And when you use an asterisk in front of a variable name here in the declaration, it's saying, hey, this is a pointer. So it's saying, hey, this is a pointer. For the value of this pointer, set it to the memory address of this number. Cool. So there's another way that we can kind of prove this. And so I'm going to print out number memory location, and we'll say 1. And then I'm going to make this number memory location 2. And I'm going to print out the memory location of number here, just to show you that it's the same thing. So we're going to compile it, run the executable. As you can see, it's the same hexadecimal number because it's the same value here. Now what I'd like to show you is how to get a value from our pointer that is the value of the variable that it references, right? So our pointer is referencing this number, and we can print out the memory location, but we can also print out the value of that variable. And we can do that by dereferencing the pointer. So I'm going to write in number value 2. So this is just another way to get that value from number. And what we can do is do a asterisk and PTR, an end line there, and clear this to get a little more clear. We'll compile our program. We will run the executable. And here we see 8 as the value in our pointer. So when we use the asterisk, we're dereferencing the pointer, meaning we're telling the compiler, hey, I know this value, the value of this variable is a memory location, but when you go to that memory location, let's grab that value and print it out and return it. So that's about it for now for pointers. There is another, this can go on, right? This is just a quick introduction to pointers. You can have pointers to pointers and it can go pretty deep. But just having this basic understanding of what a pointer is good, because pointers are sort of the backing technology behind more complex data types and arrays and things like that. So it's good to have an understanding of, at least a basic understanding of pointers right now, because it's going to be something that we reference a lot later on in this class. Thanks.